All right, class, this is your first lesson on solving systems of equations, Algebra 2 style. Your objective today is to be able to solve simple systems of equations that have three equations and three variables. Now, what is a system? What is it? It's two or more equations that share variables. And what are their solutions? They are the values of those shared variables that make all of the equations in the system true at the same time. Now, in Algebra 1, you learned how to graph two lines, and where the lines intersected, that was the solution to your system of equations. You also learned how to solve systems algebraically using substitution and elimination. And before this whole lesson is over, we will come back to both of those algebraic methods. In addition, in Algebra 2, later in the unit, you will learn how to solve with technology, specifically with matrices. So let's go ahead and build on what we already know. Suppose you had this system of equations. Well, you can see that z is equal to 2. That means you could substitute -2 for z. And I do that here. We go to the first equation and substitute -2 for z. -3 times -2 is 6. We subtract 6 from both sides. That gives us 4y is equal to 12. Then we divide both sides by 4, and we end up with y is equal to 3. So now we know the value of both of the variables in this system. The solution then is y equal 3 and z is equal to -2. This means that both equations in the system are true statements when y and z have these values. But in Algebra 2, we are focused on systems that have three equations and three variables. Like this system right here, we have added x into the mix. But still, we can see that z is equal to -2. So we can use what we already know, since we know that z is equal to -2. We can use that information to solve for y using the second equation. 4y minus 3z is equal to 18. We are going to do just like we did before and substitute -2 for z and end up with a value for y equal 3. Now that we know the value of z and y, we can back substitute to solve for x. So we go focus on the first equation, where we will substitute 3 for y and -2 for z. When we combine 3 and -2, we end up with 1. So now we have x plus 1 is equal to -22. Subtracting 1 from both sides, we end up with our value for x. That means the solution is -23, 3, and -2. This, written like this, is called an ordered triple. It looks just like a coordinate point, except it has 3 points: -23, 3, and -2. This means that when x, y, and z have these values, all three equations are simultaneously true. Systems like this, like the one that I used for this example, are called triangular systems. They are easily solved by back substituting. Now it's your turn. Get a paper, pencil, if you haven't already been taking notes, and solve this system for X, Y, and Z. Be sure to write your answer as an ordered triple with X, Y, and Z in order. And last, make a list of any questions that you had about this lesson in your notes and come to class prepared to get answers to your questions. That's it for this lesson. I'll see you in class.